Hey, welcome. Today we're going to be talking about how to solve problems for velocity and acceleration of a system of particles using the center of mass of a system of particles. So this is a key skill that you need to be able to use for AP Physics C mechanics. Alright, so let's go ahead and get to it. If we take a look at our equation sheet, we do have this equation on our equation sheet, and I'm going to show you how to use this. This is how to deal with the center of mass of a system of particles. Although I have done a screencast on that as well. If you want more details, I'm going to put a link to that in the upper right about now. But I will show you how to do that now as well. So let's take a look at this. The first thing we need to think about is we want to get to velocity and acceleration, and we start with position. So how do you get to instantaneous velocity from position? What do you think? Well, hopefully this is going to be reviewed for you, that you take the derivative of position of the center of mass with respect to time, and you're going to end up with velocity of the center of mass of the particles. So that's what we begin doing over here. And notice this is going to be what we had up here gets subbed in, because we're taking the derivative of this thing is going to be equal to the velocity of the center of mass. Then we could say, well, let's rearrange some of the variables here and see what happens. If we rearrange some of the variables and end up with dx over dt, what does that give us? Well, that's going to give us velocity, right? Instantaneous velocity here. So let's take a look at what this derived equation is. This equation is not on your equation sheet, so you're either going to have to be able to memorize this or just sub in VCM where XCM goes and VI where XI goes. I think most people can probably do that on equation day. Just use this as a reminder to be able to change over to VCM into VI here. Alright, and similarly what we're going to do is derive the acceleration of a center of mass of particles and see how to go about doing that. So we're going to do this in exactly the same way as how we did this above. What do we know about how velocity and acceleration relate? Well, velocity and acceleration relate in the sense that the derivative of velocity with respect to time is going to be equal to the acceleration. So that's true here even if we're talking about the center of mass of a system of particles. So in exactly the same way, we can show the derivation. We take the derivative of what we had done previously up here, and that's the derivative of the velocity of center mass of particles. Then we do some algebraic isolation over here so that we can get dv over dt, and that will give us acceleration for each of these instances that we can take a look at. So this literally means the acceleration of the center of mass of a system of particles is equal to the sum of all of the masses multiplied by the accelerations for each of those individual points divided by the sum of the masses. So I'm going to show you how to do problems just like this. Let's go ahead and take a look. First, though, I do want to point out how to do a center of mass problem really quickly. I do want to say thanks to Desmos, great website. I'll put a link to that in the description of my video right here down below. But just a quick recap, this is on your equation sheet right here. These two are not on your equation sheets. And so you could say, well, I don't quite remember how to do this calculation here, the center of mass of a system of particles. So I'm going to quickly show you how to go about doing that, remind you how to go about doing that. First, I'm going to add some extra information here. Some of this we'll need now, some of this we'll need later. We do need all of the masses now for these particles here, and we're going to take a look at this equation. Again, that's on your equation sheet for AP Physics C mechanics, and this is what it would look like in terms of if we plotted those points. And so we're going to say we have a center of mass at some point in between these 3 points. So where is that? Well, we take that equation and we carefully do this calculation here. Be careful, there are a lot of ways that this can go wrong. This is going to be our calculation right here, and when you do the math you end up with this value. Notice I'm just doing this in the x. You have to treat the x and the y separate, and we're going to go ahead and do that. Same thing, same equation up here, we're just going to change that to be with the y. And so let me show you what that looks like. This is the calculation for the data with the y, and we end up with this point right here. And so taking the x and the y points together, we can come up with a Cartesian point of this right here. And I'll show you on the next slide where that point would be. Here it is right here. And so that's how you go about solving for the center of mass. Now this video though is building on this. How would you go about solving for the velocity of the system of particles right here? And that's what we're attempting to do, velocity and acceleration. So first of all, we're going to take that equation that we derived previously, and we're going to say, all right, we're going to do the math here. The math is actually very similar to what we did previously. The major difference is that these velocity values in here need to be carefully done using some simple trick to make sure that you're getting the velocity in the x-axis. For instance, right here and right here, that's what I'm doing. And to also remember, some of these need to be made negative. Like v3, this is going to be moving to left, and so that needs to be a negative value out in front of this term right here. If you don't make that negative, you will get the problem wrong. So we continue with the math, and we end up with this answer for the center mass in the x. We're going to do exactly the same thing in the y, and so that's the work that you see right here. And we end up with this answer in the y. If you need to pause and want to check the math, go for it. Notice I'm beginning to write these vectors over here as well. That's where we start, but we want to think about what is the overall velocity for this system of particles, and that's what we're attempting to do. So what do you think we're going to do at this point to be able to solve for the overall vector? Well, notice I'm using the head to tail method here, the head of one vector to the tail of another vector to be able to find our final vector. And of course, to do that, we are going to use the Pythagorean theorem, so I'm going to show the work for that here. You do the Pythagorean theorem, that's going to give you this vector over here, and I'll show that to you right now. So the velocity of the center mass of this system of particles is going to be given by this value. Now, a logical follow-up question that you would have that you need to be prepared for is, what is this angle over here? Hopefully that's going to be a review for you. You probably already know how to do this, but I'm going to show you really quickly what you could do. You take that vector and you make it into the hypotenuse of a right triangle. You know this leg, you know this leg, and so you can use an arctangent here. Let me show you. Start with tangent. You know these two values. You don't know the angle, so to get rid of the tangent function, you take the inverse of tangent. So this is going to be our arctangent of what we had previously. We can go ahead, plug in our numbers, and we get our answer for this angle. That's how you go about doing it. You would do exactly the same type of calculation if you were going to do an acceleration calculation. It's just that instead of the velocity vectors, you would be using acceleration vectors, but it is exactly the same as what I just demonstrated. So hopefully that's been helpful. If you have any comments down below, please let me know. I've done basically a year of physics concepts as well as many concepts in AP Physics, so if you want to see more, take a look at the playlist as well. Have a great day.